Hi, this is Lori, and this is my homework for Paul McWhorter's Pico W course, lesson number 33. And this will also probably cover lessons 34 and 35, where this work gets incorporated into our portable weather stations. I'm way behind. I've been traveling and just weren't in a place where I could do a lot of electronic projects, but I'm back home for the winter, so I'm excited to try to get back into the course and hopefully catch up with the lessons. I'm not going to incorporate the use of the HSV to RGB conversion into my project. I'm going to kind of skip over that. I think it's pretty easy once you get it working, and I really do like having very distinctive colors to indicate temperature or the wind speed. I think it's actually pretty hard to tell small differences in color shades myself. I think it's more fun to loop through colors just because it's fun to loop through colors and do cool things with LEDs. So that's what I'll kind of do in a couple of the programs that I write using my function, but I'm not going to put it into my my project, and I'm going to just try to move ahead in the course. So for the homework, Paul asked us to create our own code to go from a hue represented by 0 to 360 degrees, that particular color, and turn it into an RGB code that we could use with our LED. And the intention was Paul wanted us to be able to sort of use the color wheel and loop through these colors nicely using hue, going from, through the degrees, to indicate things like temperature and wind speed and things like that in our weather station project, as a smooth sort of color transition, and using hue as the way to do that smoothness and to use the particular colors of the color wheel. So that was great, because that's something that I've looked at a couple of times and decided I just didn't want to dig into it at that moment. But I have seen that, you need to often go between hue, saturation, and value, which is easier to loop through, but your LED wants the RGB codes. So you have to make that switch, and I've looked at that a couple times, but I haven't really gotten it in my mind of why these crazy formulas work. As Paul was saying, it's very confusing. And so I thought this is the time, because, Paul gave a nice start on understanding how the hue was turned into an RGB value, and I decided to go ahead and take the other two pieces of the HSV model, the saturation and value, and try to make sure I understood those as well. So if you look up the definitions of saturation and value, one, you'll see that they go from 0 to 1, and as you can see on this description of the space, the hue, saturation, and value space, it's sort of a cone shape, and as the value reduces and as the saturation reduces, you get down into an all black color. So that's kind of how you get to that. And you can see that, as you do it, your wheel gets smaller and smaller as your value reduces. So saturation is the intensity of a particular color, a particular hue, and higher values give a bright or pure color, and lower values get kind of dulled or grayed out. So kind of shown here with this diagram here. And then value and brightness is the lightness or darkness of the color. So here's an example of sort of a teal. You can kind of compare it to a grade scale, and you can see how it's sort of becoming lighter and lighter and lighter as you reduce the value. So that's what those two pieces do, and that's not necessary for the project that Paul assigned as our homework to use those, but I'm basically setting them to 1 for our project. But it does help to understand, and if you really want to make a function that'll do HSV to RGB, then you really do want to build in your saturation and value parts. So I decided to add that to my homework for myself. Now Paul, he used a color wheel a little bit different than the ones I've seen out there. He did the color wheel kind of in what I would say was reverse to what you mostly see out on the internet. And he went sort of backwards with the degrees, and it doesn't matter, you just have to pick a direction. But I decided to go with what I saw out more on the internet, that the wheel goes this direction, and so magenta, instead of magenta being 60, 60 is actually yellow, and magenta would be 300 degrees. So I went this direction through the wheel. But Paul did a great job of just showing us how to take, these points on the wheel and kind of create a graph where we could see how the red, green, and blue values changed in each section sort of this, of the 360 degrees. You can see there's always one is the max, the other color is the min, and then there's one sort of transitioning in each set of 60 degrees. So that's kind of important. And that means that there's never more than two colors on at the same time as you move through the wheel. You always have one that's off and the other two potentially on. It can be that there's just one on, like when we look at red, there's only one channel that has a value, and same for green and blue. But then the transitioning colors, you can see as you go around, there's always just two contributing when you're just looking at hue to RGB. So that was really helpful, and I really appreciated how Paul put this graph together and showed that to us. So when saturation and value are 100%, and there are never more than two colors on, and we're just kind of looking at the bright pure color for the color, for each color along the color wheel. And so here it is in the direction that I chose to go, where 60 degrees is yellow, and then we go to green and cyan, blue, magenta, and then back to red. And so I adapted the graph that Paul had shown us to reflect the direction that I decided to go in. And here's the way this looks. And this graph is just really important for figuring this thing out, and it just makes it a lot more simple once you get this piece of it to now build in the saturation and value piece of it to the graph. So I just thought I'd share one of these conversion formulas that I'd found in my initial attempts to understand converting HSV to RGB way back when I first took a look at this before Paul did his lesson on this. And this was one of the formulas I found, and it's something you can follow, and if you know a little bit of algebra, you can at least code this up, but it's just very confusing. And you can see here's our hue, here's our saturation and value, and then you have to calculate these values with kind of not much explanation about what they are, and then this thing called X, and then depending on which section of the wheel you're in, and you can see that it has to do with the fact that you kind of divide up that wheel into 60-degree segments, then you can get your RGB prime. So those are kind of normed on a 0 to 1 scale, and then you scale them back onto the 0 to 255 scale if that's what you need. So you could certainly take this and just code it, but when I looked at this, I was like, what is this X, and why are we doing H divided by 60 mod 2, and it's an absolute value, and it's because somebody was very clever and figured out a way to do this calculation, maybe efficiently, I guess, but it's very hard to figure out, how are they coming up with this, and how did they figure that out? So I just thought I'd share that you'll see these kinds of things, and some that are slightly different, but pretty similar. If you would just go up and look and say, how do I do this conversion? This was the graph that I put together to help me understand how to make a conversion formula going from the HSV to the RGB. And I learned about that the value was the max that the color could be, any channel could be, and the min and the range from looking at some of those formulas, the conversion formulas. A few of them actually named some of these equations, and so I got that part of it. But I will say one of our other students in the class, Pascal Jobin, if I'm saying his name right, I hope I am, he did a fabulous job of demonstrating this with a internet conversion tool to show us that this is what happens with the value when it's less than 1, and this is how the min changes when the value and saturation are less than 1, and that we get to this constrained range inside of the 0 to 255 scale, or 0 to 1 if we norm our RGB values. So I definitely recommend looking at his video. It's excellent. But that's kind of how I got to this graph. And so here's the graph that Paul put together for us, but now the max isn't necessarily, the min isn't necessarily 0 and 1, but it's value, and value times 1 minus the saturation is the min when those are not equal to 1. And we get this reduced range of V times S in those cases. But the pattern remains the same. One's a max, one's a min, and a color is in transition in each section of the color wheel. And I numbered these 0 through 5, and you'll see that in my code that I try to figure out what section am I in, and then I know which color is in transition, because I've got the formula for the min and the max, so I know what, for example, if the hue is in this section, then I know what blue should be, I know what red should be just from the value and saturation values. But knowing what the green should be, well, I need to know the formula for this line, and specifically I need the slope of this line. And so as I started thinking about it, I mean, slope is simple. It's just the change in y over the change in x. And so if I go from 0 to 60 degrees, my change in x, I now know that the range is the value times the saturation. So the change in y is v times s, and the change in x is 60 degrees. So that's the slope, and it's either positive or negative depending on which section we're in, and in which color is the one in transition. So that's how I wrote my code. It is not the most efficient code out there, and I think it's readable and understandable, but at least to me, but it's definitely not the most efficient way, and not the way you'll see it if you go look up and say, what's the conversion formula for HSV to RGB? You won't find my way of doing it, but my way was just so I could really understand how we came up with these numbers, and so that's how I went about it. So let's go take a look at my code. So just a quick reminder of what my layout looked like for my weather station. I made a little addition here. I decided to add in an RGB, a regular RGB LED to the circuit. So I kind of have that wired up here. Kind of looks a mess, but I'm trying to keep it all down so we can still see the Ring NeoPixel back here. And then I had the breadboard NeoPixel, and then the Ring. So the first couple of programs will just use these, and I'll put some diffusers on them to help see the colors, and then we'll look at the Ring NeoPixel. Here's my function to convert from HSV to RGB. We'll assume that the hue is provided as 0 to 360. The saturation and value will be on a 0 to 1 scale. And if 360 is set as the hue, then we'll do this modulo to turn it into a 0 degrees. And then we'll determine which section of the graph we're in. So are we in the 0 to 60, 60 to 120, so section 0, section 1, all the way up to section 5. So we'll do the hue divided by 60, take the integer, and that'll give us the section. Then we'll do some of the basic calculations that we need to do. We'll get the value and set that to the max RGB, and then the min will be the value times 1 minus the saturation, and the range will be value times saturation, and we'll get that slope, which is the range over 60. So that's all the basic calculations that we'll need. Then we'll go section by section and figure out what the normalized R, G, and B values should be. And so in section 0, we know that R is the max, so we'll set that to the max, and we know that blue should be the min, and then we know that G is the transitioning color, and we'll figure out, use the slope, and we'll figure out how far we are into that section. So we'll subtract the beginning of the section from the hue and multiply that by the slope, so that tells us what that value for the green will be. And we'll add on the min to get where we are on that scale, and that'll be G. And then the same logic works for each section. In the next section, we know that R is the changing value and G is the max and blue is the min. So here you can see. And now though, remember the slope is decreasing in this section. So we'll take away how far we are over and the Y value for that from the maximum so that we drop down and get that R value right at the spot of the hue. So that's how that works in either case, and then we just keep doing it for each section, whether it's positive or negative, and switching which one is the changing color, and that'll get us our normed R, G, and B values, and then we'll put them back onto a 0 to 255 scale and turn them into integers and return that out of our function. Well, the first function I put together was just one to kind of test out the program, and so we'll allow the user to input a hue, saturation, and value, and then it'll give back the RGB value. It'll put that all on our display, and we'll light the two NeoPixel and the RGB. We'll light those two, and then let it come back and ask the user for a new hue, saturation, and value. All right, so just setting everything up. I'm importing that function that I just showed you how I wrote. So I put it in a separate file on my Pico and importing that, setting up the NeoPixel and the RGB LED, and also setting up the display. And then here in the while true loop, we'll ask the user to give a hue, saturation, and value. We'll put those in, we'll do the conversion, and then we'll put that color onto our NeoPixel, and we'll put that color onto our RGB LED. And you know, with MicroPython, we'll have to use, instead of 255, we'll have to scale that up to use the full 16-bit range that this duty function is expecting. And we'll just write that information to our OLED. We'll sleep 5 seconds. We'll clear everything out and kind of go back around again and let the user put more in, and we'll stop when we do a keyboard interrupt. All right, so let's see this go. All right, so we can enter a hue. So let's do a real simple one. We'll do red first, and we'll do full brightness. So hopefully that'll work. And I think you can see that we've got red there. All right, so let's try a different one. Let's try about 60 degrees and maybe a saturation of 0.7 and a value of 0.8. There we go. And you can see it's got a little bit of color to it, but it's also fairly white. So when you start messing with those, you can turn it almost bright white pretty quickly. How about we try a magenta type color? So we'll enter a hue of 300 and a saturation of 1 and a value of 0.5. And there's our magenta. So it seems to be working all right. Well, in this program, I decided to just kind of loop through the color wheel and just rotate on through. So we'll set everything up just as we did before. And here we'll loop through the different hues in 5-degree increments and put them both on the NeoPixel and the LED. And in this case, we'll have full brightness, full saturation, and full value, I guess we should say. And it'll just keep looping until we stop it with a keyboard interrupt. Well, let's watch it go through the colors. And I am noticing that my iPhone is adjusting to the color brightness a little bit as we go. So now we should just see it, you know, moving through the colors of the color wheel. Yeah, it's kind of fun. Hopefully it's showing a little bit on the screen here. Getting to red, back to yellow, coming into green. Yeah. Moving towards the blue. And magenta. And then back to red. All right, so that works pretty well. And that's the nice thing about using the HSV. It's much easier to loop through the colors that way. All right. last program. Well, I got that NeoPixel ring, and you think about the color wheel and you look at the ring and you think the two should be put together. So this last program uses the NeoPixel ring, so we'll set that up, and we'll assign to each pixel the color that it should be for kind of that position in the color wheel. So we'll go through those in 15-degree increments because it's 24 pixels, so that works out to 15 degrees per pixel. So we'll light them up and cycle through, and then we'll sleep for a minute, and then we'll clear them out and start over again. So it should be kind of fun. It should sort of rotate through the ring, and we should see all the colors, and then it'll clear out and start again. Hopefully it'll work. All right, there we go. Yeah, it's looking okay on the screen. It's really nice in person. It's much more spectacular, actually. Looks great. That's a lot of fun. I could look at this for 10 or 15 minutes, it seems like. Well, that's what I put together for this homework, and that's kind of what I'm going to do for the next 34 and 35 lesson as well. That's where I'll stop and move on to the next lesson after that. Thanks, Paul, for the great set of lessons, and thank you for watching.